The Soviet Union's obsession with Venus during the Cold War is one of the most fascinating and enigmatic episodes in the history of space exploration. Imagine, if you will, a nation locked in a fierce competition with the United States, each side racing not just for scientific breakthroughs, but for global supremacy in the newly emerging frontier of space. Amidst the geopolitical tensions of the time, the Soviets turned their eyes to one of the most hostile and inhospitable planets in the solar system, Venus. A world that, despite its many similarities to Earth, was an absolute nightmare for any space mission. With temperatures high enough to melt lead, an atmosphere thick with toxic gases, and pressure so immense it could crush a spacecraft, Venus was widely regarded as an impossible target. Yet, between the 1960s and the 1980s, the Soviet Union launched 16 missions to this boiling hot planet, nearly all of which ended in failure. Despite these failures, the Soviets doggedly continued their pursuit, investing enormous resources and pushing the boundaries of technology in ways that were truly extraordinary. Why, then, would a nation with such limited resources at the time continue to throw everything at a planet that seemed utterly unreachable? What drove the Soviet obsession with Venus? Was it pure scientific curiosity, or was there something more at play, a desire for political and technological prestige? And what did the Soviets really hope to achieve from exploring a world that had been deemed by most as a hopeless endeavor? As the decades passed, the world began to uncover the real story behind the Soviet Union's Venus missions, shedding light on what was truly happening behind the Iron Curtain. In the years following World War II, the Soviet Union found itself locked in an ideological and military rivalry with the United States that would come to define the Cold War. The Soviets sought to assert their dominance on the global stage, not only through military might but also through technological achievements. The space race, which began in earnest in the late 1950s, was a perfect opportunity to demonstrate the Soviet Union's technological superiority. In 1957, the Soviets launched Sputnik 1, the first artificial satellite, into orbit, marking the beginning of the space race. This event shocked the world and left the United States scrambling to catch up. The space race wasn't just about exploring the unknown, it was about proving to the world that the Soviet Union was a powerful, advanced nation that could achieve the seemingly impossible. At the height of this intense rivalry, the United States had already begun to make significant strides in space exploration. In 1962, the U.S. launched the Mariner 2 mission, which became the first spacecraft to successfully fly by Venus and send back data about the planet's inhospitable conditions. The information gathered by Mariner 2 revealed that Venus was a place of extreme temperatures, crushing atmospheric pressure, and a thick cloud cover that made it nearly impossible to study the planet in detail. For many in the scientific community, this discovery confirmed that Venus was a planet that couldn't be explored, at least not in any meaningful way. However, the Soviet Union, driven by both scientific curiosity and the desire for political advantage, decided to take on the challenge. Despite knowing that Venus was essentially a hellish planet, the Soviets saw an opportunity to outdo the United States. They decided that they would send probes to Venus, not just to observe it from a distance, but to land on its surface, take pictures, and gather data. This was a daring move that would later come to symbolize the audacity and determination of the Soviet space program. Between 1961 and 1984, the Soviet Union launched a total of 16 missions to Venus, each more ambitious than the last. These missions were part of the Venera program, and although many of them failed, they would eventually lead to remarkable successes. The early years of the program were fraught with difficulties. The Soviet Union faced numerous technical challenges in designing spacecraft that could withstand the extreme conditions on Venus. The temperatures were so high that conventional materials would melt, and the atmospheric pressure was so intense that it would crush most spacecraft. Yet, the Soviets persisted, using cutting-edge technology to develop probes that could survive these hostile conditions. One of the main technological breakthroughs of the Venera program was the development of heat-resistant materials and protective shielding for the spacecraft. Engineers designed probes with thick insulating layers to protect the sensitive equipment inside. The Soviets also pioneered the use of specialized cameras that could take photographs in the extreme conditions of Venus's surface. Despite the overwhelming challenges, they continued to improve their technology, launching mission after mission in an attempt to land on Venus and send back valuable scientific data. The first significant success came in 1967 with the launch of Venera 4, which became the first spacecraft to transmit data from the atmosphere of Venus. Although it didn't land on the surface, it provided vital information about Venus's thick clouds, extreme heat, and toxic gases. Following Venera 4, the Soviets launched a series of missions, each more ambitious than the last. Venera 5 and Venera 6 both successfully entered Venus's atmosphere, but neither was able to transmit data for long. It wasn't until 1970 that the Soviets achieved their first true success when Venera 7 successfully landed on Venus, becoming the first spacecraft to transmit data from the surface of the planet. The achievement of Venera 7 was a landmark moment in space exploration, and it sent shockwaves through the scientific community. For the first time, humanity had direct data from the surface of another planet. The images and readings sent back by Venera 7 confirmed that Venus was indeed a hellish world, with temperatures approaching 480 degrees Celsius (900 degrees Fahrenheit) and a thick, sulfuric acid-laden atmosphere. Yet, the Soviets were undeterred. They had proven that landing on Venus was possible, and they were determined to push further. Once completed, the Vera Rubin Observatory will be able to track the movements and patterns of TNOs with incredible precision. By doing so, astronomers hope to narrow down the location of Planet 9 and eventually confirm its existence. Brown and Badigian have already used their simulations to predict the areas of the sky where the planet is most likely to be located, and they are hopeful that the new telescope will be able to find it within a few years. If Planet 9 is indeed out there, the Vera Rubin Observatory may be the key to unlocking the mystery of its existence. The discovery of a ninth planet would have profound implications for our understanding of the solar system. It would force us to reconsider our current models of how the solar system formed and how its various objects interact. For centuries, astronomers believed that the solar system consisted of just the 8 planets, with Pluto being relegated to the status of a dwarf planet. But the idea of a ninth planet, one that has remained hidden for so long, challenges our assumptions and opens up new possibilities for exploration and discovery. It also raises the question of whether there could be even more planets in the solar system that we have yet to detect. As technology advances and our ability to study the outer reaches of the solar system improves, it is entirely possible that we may uncover even more hidden planets or celestial bodies lurking in the darkness. The search for Planet 9 is not just about finding a new planet, it is also about understanding the history and evolution of our solar system. The fact that such a massive object has remained hidden for so long suggests that our solar system is far more complex and dynamic than we once thought. It also suggests that there may be other objects lurking at the edges of the solar system, waiting to be discovered. In a way, the search for Planet 9 is a journey into the unknown, a quest to uncover the secrets of our cosmic neighborhood and to better understand the forces that shape the solar system. At the same time, the search for Planet 9 also highlights the power of mathematics and computer simulations in modern astronomy. Brown and Badigian's work is a prime example of how advanced mathematical models can be used to make groundbreaking discoveries. Just as astronomers in the past used mathematical predictions to discover Neptune, the same techniques are being employed today to search for Planet 9. It is a testament to the power of human curiosity and ingenuity that we are able to search for objects so far from our reach, and it serves as a reminder of how much we still have to learn about the universe. Despite the excitement surrounding the discovery of Planet 9, not all astronomers are convinced that it exists. Some researchers have proposed alternative explanations for the orbital anomalies observed in the TNOs. One such theory suggests that the gravitational effects of the many objects in the Kuiper belt, including Pluto and other dwarf planets, could be responsible for the observed clustering of TNOs. According to this theory, the combined gravity of these objects might be enough to explain the unusual orbits without the need for a massive, unseen planet. While this theory is intriguing, it has not yet provided a definitive explanation for the anomalies observed, and the hunt for Planet 9 continues. As we move forward in our search for Planet 9, the excitement and anticipation grow. The discovery of this hypothetical planet would be a monumental achievement in the field of astronomy, one that would reshape our understanding of the solar system and our place in the universe. It would also inspire future generations of scientists to continue exploring the farthest reaches of our cosmic neighborhood, seeking answers to questions that have eluded us for centuries. The search for Planet 9 is a reminder of the vastness of the universe and the boundless potential for discovery that lies just beyond our reach.